Thank you for joining me for this PMGT 730 Risk Management Term Project. I'm Sheila Donnelly, and today I'll be discussing how risk is managed for prescribed burns in the forestry industry. Next, I'll walk you through today's agenda. In this presentation, I'll be giving a background of the forestry industry. I'll explain the purpose of prescribed burns and their place in protecting our forests, a brief history of prescribed burns. I'll explain how the risk of prescribed burns are identified. I'll go through how risk analysis are completed, including how risks are prioritized and managed for such a dangerous task, and we'll look at how risk responses are created and managed. And lastly, we'll look at how these risks are monitored throughout fire season before summarizing the details of this presentation. Next, I'll take us through the forestry industry background. The forestry industry is part of the economy engaging in management of global woodland areas with focus on maintaining timber, wildlife habitat, biodiversity, recreation, and clean water. This industry employs an estimated 33 million people worldwide and contributes to 1 to 2% of the global output annually. Some of the roles in forestry include loggers, tree planters, park rangers, firefighters, and manufacturing corporations. Forestry provides the materials to frame and build homes, make furniture, build decks, fences, paper, napkins, packaging, and so many other products that we use in our daily lives. The average price of lumber is $550 to $650 US per 1,000 board foot, though Canada has historically sold it to our neighbor down south at under $500 per 1,000 board foot to promote good relations. Canada is the highest lumber exporter in the world, trailing China, and accounts for 1 to 2% of the world's lumber trade, supplying 1.2% of our GDP, or $33 billion, to our economy. Some current issues affecting the forestry sector include geopolitical tariff threats, human exploitation, overharvesting, poor research conservation techniques that result in biodiversity losses, and depletion due to natural causes like fire and infestations. Next, I'll take us through some details about Earth's forests. Earth's forests are comprised of 5 regions, while the full boreal covers the entire northern hemisphere, not only supplying us products, but also acts as the lungs of the planet, influencing our climate, temperature, and oceans. Canada's portion of the boreal covers half of our country, and at 25% of the forests, it also houses the largest intact portion of forests in the world. With boreal included, Canada houses the world's 3rd largest forest area of nearly 362 million hectares, or 40% of its land surface area. The forestry industry in Canada is especially important, with our lumber being of tighter grain due to careful stewardship and tempering of trees in the colder Canadian and Arctic temperatures. Next, I'll look at why forest conservation includes carefully controlled fires. While it may seem counterintuitive, fire is actually critical to the natural ecology of many ecosystems. Habitats recover quickly from burns, and fire helps prevent invasive woody overgrowth. It also removes unhealthy buildup and returns stored nutrients back to the soil. Many trees, including oaks, have mechanisms to embrace the fire and protect the tree and promote seed growth. It's also a part of restoration plans for sensitive and endangered areas, and strategically placed burns can provide a fire break used in suppression of out-of-control fires during the summer months. Fires are prescribed in early spring with extensive burn experts on site before the reptiles emerge and the birds nest. Conducted by professional fire staff trained in fire behavior and fire control. So if you live in an area with a burn in the previous year, I highly suggest to return in the summer months the year after for either a beautiful floral display or an explosion of the sought-after morel mushrooms if you live in Northern Territories. Next, we'll take a look at the history of prescribed burns. Prescribed burns have been used for thousands of years by the first peoples to allow more diversity among native plants and berries, making space for them and allowing them to thrive. These spaces also allowed for more grazing for animals to hunt. Binaziguak Anishinaabe is the Anishinaabemowin or Ojibwe name for the traditional and prescribed burn, meaning a responsibility for a cleansing burn by all Native people. While controlled burns were temporarily wiped out during colonization in the early 1600s, the disruptions to the ecosystem forced European settlers to learn the forestry stewardship of the First Peoples and embrace the vast benefits of the forestry strategies in the early 1900s. Since then, regulating bodies in the country now work together with Indigenous bands to facilitate the ancient practice of effective forest management in North America. Now, we'll have a look at the risk identification process when performing prescribed burns. As you can imagine, risk ID can get quite complex when planning a fire of this size, surrounded by forest or grassy areas. While there are pastel considerations for major forestry operations, this presentation focuses on the intricacies of safety risks for prescribed burns, as safety factors have a comprehensive risk management process in place to prevent danger to the public, wildlife, and natural habitat. These plans were developed from generations of knowledge, success, and lessons in a system that continues to learn and grow. For prescribed burns, first, an expert, called a burn boss or a fire boss, will begin a burn complexity assessment by reviewing known risks like vegetation type, local weather conditions, burn area, and crew knowledge. This assessment is only available to certified burn bosses with access to a CD not available on the internet to ensure it's used by expert professionals only. Once the complexity result is found, the amount of detail needed for a burn plan is decided, with much more detail and expert involvement for highly complex burns. Risk considerations include community concerns and reactions, health and safety of the crew, health and safety of the public, damage to forests outside of the burn zone and nearby structures, wildfires, danger to wildlife, unideal weather conditions, availability of suppression or PPE equipment, coordination among teams, management and regulating bodies, sufficient fire suppression supplies, natural or not natural, i.e. streams or fire trucks, proper funding, smoke inhalation in nearby communities, and by crew. Areas of strongest consideration in these assessments include sensitivity to smoke, as prescribed burns usually produce a large amount of smoke in the area. And again, we are aiming for the smoke to go straight up, so windless conditions are ideal. Human safety, so areas are close to vehicles, cyclists, and pedestrians during the burn. And wildlife safety, so these are scheduled when birds are not nesting and before hibernating animals emerge. A thorough assessment is performed of all wildlife, nesting habits, and migratory patterns in the region, and a similar assessment is performed for the area's vegetation to identify plants that could be damaged or ones that catch fire more easily in the burn area or region. Sites are intentionally small and patchy to allow escape routes for wildlife and insects, while preserving unburned areas for pollinators like bees, in addition to wildlife sweep immediately before the burn, where an entire line of staff lines up along the length of the site and walks through to encourage wildlife to run or retreat to underground nests where they will be safe. As well, a full aerial pass is done if it is an aerial ignition. According to Ontario's fire management strategy, fire plans and assessments then go through stages of rigorous permit and regulatory applications, including the Ministry of Natural Resources and Forestry, ensuring expert involvement at all phases of the burn. The next slide shows an example of permit and approval schedule for a burn. These permits are required to proceed with a prescribed burn with approximate timelines for approval. Timelines range from 17 to 25 months depending on region and complexity. Next, we'll have a look at the risk analysis process. Site risks are assessed by the fire boss, expert analysis, existing fire models, and the regulators that will be approving or rejecting the burn plan applications. Here, the burn boss accepts the risks of the burn plan being rejected, as this is quite common in industry and there are processes in place to submit revisions to the part of the plan that regulators don't find acceptable. For the safety assessments, the burn area boundaries are drawn on a map and visited so the experts can properly identify and analyze the vegetation, wildlife, weather patterns, and objective feasibility of the area. Data is collected for all factors to come up to determine impact, severity, probability, and mitigations that exist to minimize or avoid the risks. In the cases that expertise is needed or too much uncertainty exists, risks are then escalated to experts for further analysis. Arguably, another stage of risk assessment exists in the regulatory approval steps, as they provide other layers of assessment if the fire boss or crew missed or misjudged risks on the list. Next, we'll look at how the team responds to the risks of the prescribed fire. For risk response planning, extensive contingency planning documents are prepared, including standard processes in case of burn deviations. While many mitigations are on this plan, most are centered around effective communication, knowing who to contact and what information they'll need to perform the next steps. Problematic control notification policies are developed with explicit contacts for immediate notification in case of emergency. To respond to smoke risks, residents are all warned well in advance to stay indoors if smoke blows into their neighborhood, and full weather reports and analysis are done in advance of the burn to aim to prevent ignition before ideal weather conditions for smoke and fire are in place. Basically, they want the fire to go straight up, ideally. Natural waterways and fire suppressions are identified. Medical emergency and transport staff and vehicles all have designated locations and contact information, all made available to crew members, and all crew is extensively trained in the burn area, objectives, safety locations, contacts, safety procedures, and what circumstances would trigger any emergency procedures. PPE requirements are checked and double-checked, and traffic control crews are assigned their respective areas. As well, many crew are trained to be real-time lookouts to watch for deviations from the plan and injuries during the burn. Like the other risk management activities, monitoring is taken very seriously, driving documentation for future burns and the safety of our communities. Monitoring includes reporting health and safety deficiencies to the prescribed burn fire boss, documenting a ledger of expenses, indirect and direct, before and after the burn to track materials and labor by job size and complexity, monitoring for objective completion, monitoring for invasive species rooting before the native species have a chance to regrow, and an appointed contact for the fire assessment report is also designated in case of a wildfire, and they would report on points like how the burn deviated from the original plan, the expected weather, the fire behavior, and the recommended course of action to minimize costs and community impacts. Photos are also collected before and after the burn for a burn report, documenting areas established to record all data. In summary, forestry is a very interesting and challenging industry, subject to so many uncontrollable factors, particularly with weather, human activity, government, and economic considerations. Being environmentally responsible stewards of one of the largest forests on Earth has responsibility, so thank goodness Canada readopted prescribed burns for forest management, even 400 years a tad late. This project has given me new appreciation for risk management templates and processes. While not all project types can have this much consistency, the impressive system of detail, risk assessment, and management ensures that all details, contacts, contingency plans, backups, and emergency safety are completed, documented, trained, and distributed. While the rigorous regulatory checks make crews endure many checks from multiple authorities, all of these are put in place to make sure that the utmost care is taken to protect and maintain our forests. Thank you again for joining me for this presentation about prescribed burns risk management in the Canadian forestry industry. Wishing you all a wonderful and safe summer. Take care.